Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about NASA wanting to bring a rock back from Mars at some point in the future. And if I have time, we're going to talk about NASA's new direction for the future. And of course, we're taking listener questions about all things in the universe, because this show is about the entire universe. We record every Thursday at 4 p.m. Eastern, so call 888-581-0708 to join the conversation. And in today's Blue Shift, I'll be talking about the supermoon. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at COSI, and for the next half hour, your agent to the stars. We've got an exciting show for you today on Space Radio, where we talk about all things space, astronomy, astrophysics, rocketry, science, and society. If it's above the Earth's atmosphere or even in it, it's in this show's universe. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus, so call 888-581-0708. Light it up. You can also follow along on the live streams on YouTube, Facebook, and Twitch. If you don't know what Twitch is, ask your kids. Check out spaceradioshow.com for the links. You can also follow me directly on Twitter, Facebook, and Instagram. I'm at Paul Matt Sutter. We'll take questions that you send there too. Seriously, folks, I've only prepped 10 minutes of show material tops, so get those calls in. Before I start taking calls, I wanted to share some interesting bits of news recently. And the first thing I saw this week was the official NASA announcement of the Mars 2020 rover and its mission, its design mission, to collect a sample of real Mars dirt and bring it back to Earth for further study and analysis. Just like we have samples of lunar regolith, of dirt from the moon that we've brought back to Earth, and we're testing it, we're scanning it, we're heating it up, we're dropping it off cliffs, whatever scientists do to study dirt from other planets and other objects in the solar system, we're going to do that with Mars. But Mars is a little bit more complicated than the moon, because Mars is kind of far away. So the plan to get a sample from Mars, check this out, is to fly out, send a probe out to Mars, and the Mars 2020 rover is going to do just that. Guess when it's going to launch? 2020. But it's probably really going to launch in like 2022 or 2025 or some years after 2020. Hopefully they keep the name. And it will rove around the surface. It's very similar to the current Curiosity rover that's on the surface of Mars right now. And it will rove around doing its science experiments, doing its all sorts of cool stuff. And it's going to scoop up some dirt. It's going to scoop up some dirt and put it in a can, seal up the can, and then leave it there. And then go to another spot on the surface, scoop up some dirt, put it in another can, leave the can there. And it's going to collect a few of these cans on the surface. And that's it. We haven't really thought about what's next. That's about as far as we got in the planning process. That's basically what we have the money for. We have the money to collect the dirt and put it into cans. We don't yet have the plans to go and retrieve the cans of Martian dirt and bring it back to Earth. That will be the responsibility of some other generation of scientists and engineers and space probes to go to the surface of Mars, collect the cans, shoot them out of Mars, and bring them back to Earth so that they fall into the Earth safely and we can crack them open and study them and hopefully not contract some horrible Martian disease from a little microbe that's been living there unmolested for billions of years. But hopefully that doesn't happen. This plan, it's a good plan. The reason it's a good plan, even though I make fun of it, is Mars is super far away. And going to Mars is a completely different problem than going to the moon. The missions are a lot longer. The designs are a lot harder. To get something off of Mars is much, much harder than getting something off the moon. So we can't just do a sample return mission like we do with the moon, or we do with asteroids, or we do with comets. Mars is just so much harder because it's so much further out and it's so much more massive than the moon. It's harder to lift stuff off. So that's the best plan, even though I tease it. That is really the best plan for returning a sample from Mars until we actually send people there. Maybe we're going to have to send people there to actually physically pick it up and bring it back. Maybe that's the next plan. I don't know what we've got going on past 2020. We're going to have to wait for the Mars 2040 rover. Anyway, this is Space Radio, and that's the latest and greatest when it comes to space. It's time to have a conversation. Remember, you can call it 888-581-0708 to talk. I'm Paul Sutter, and this is Space Radio. And now it's your turn.
Give me a second.
Okay. He's going to set it up so you can record on that microphone. And there you are in the live stream. Wave hi to the world. Hello, YouTubers. Please be nice to Hannah. The YouTubers can be a rowdy bunch, as you might imagine.
Yeah.
Especially when they're live and there's no permanent record of what they've said. They're basically always making fun of me. This entire stream is teasing me. I see you guys. Mooney McMoonface. You guys. What is my favorite fruit? What is my favorite fruit? Pineapple? I don't even know. What's a fruit? Cheetos. All right, you ready? All right, so I'll introduce you and then we'll just have that chat. Oh, Greg's got to set something up.
If you're going to be looking at her, I want you off my...
Yeah, there we go.
See, you have the best producer ever.
I do.
History
Greg is
producer.
really great.
Yes.
YouTube live streamers, isn't Greg awesome? Give the channel a like, a subscribe if you think Greg is awesome. That's how we do it. People are saying hi on YouTube. All right, now Greg's ready to go. I have a special guest actually in the studio with me. We've got Hannah, a local 7th grader who is doing a thing for her school that honestly I don't fully understand, but it involves not going to school and then going around and talking to incredibly smart and successful people. She couldn't get bookings with any of those, so she came here to Space Radio to talk to me. Hannah, how's it going today?
It's going good.
All right, I suspect that you have a few questions about space.
Yeah.
Okay, that's a good suspicion. Throw something at me. Just toss something at me that you think is going to stump me.
How big is a black hole?
Ooh, how big is a black hole? Well, check this out. Black holes come in all sorts of different sizes. They don't come in all sorts of different shapes. They're all pretty much round or slightly squished at the top. But they do come in all sorts of different sizes. The smallest black holes that we know of are formed from the deaths of massive stars. The cores, the leftover core of a giant star, a star at least 8 times more massive than our sun, when it dies, it either becomes a neutron star or a black hole. Those black holes have a mass of a few times the mass of the sun. So starting around 2 or 3 times more massive than our sun, going up to a few dozen times more massive than our sun. They're relatively small. They're about the size of a city. They're just a few miles across. They are incredibly dense objects. There are bigger, much bigger black holes out there in the universe. We call these supermassive black holes. These giant black holes sit at the hearts of galaxies. We have one in the Milky Way. Every galaxy, Andromeda has one, Triangulum has one. All the galaxies that we can spot have a giant black hole in their center. These things weigh hundreds of millions to tens of billions of times more massive than the sun. They are gigantic. If you were to put one of these beasts inside our own solar system, it would extend out to the orbit of Jupiter or so. These are truly giant black holes. Recently, we've begun to discover some of the medium black holes that are maybe 10,000, 100,000 times more massive than the sun. And if you were to put those in our own solar system, they would stretch out. They would be like the size of our sun or so. So there's a pretty good range between the size of a city and the size of a solar system when it comes to black holes. Theoretically, there are some microscopic black holes. And this is, I want to emphasize the word hypothetically. because we're not 100% sure on this. This is based on some relatively new thinking in particle physics. And in some of these theories, just some models, when you have a high energy reaction, like in a particle collider, you create a spray of new particles. You can also make microscopic black holes. These are black holes that are tinier than an atom, tinier than a proton, tinier even than a quark and electron, just super duper tiny, just tiny. And they evaporate almost instantly. They just go away. So they don't really affect anything. We're not going to destroy the Earth with our particle colliders. But that's still super theoretical. We're not 100% sure on that. But when it comes to bigger black holes, at least 2 or 3 times more massive than the sun, we've got all sorts of sizes: small, medium, and extra large. We kind of skip the large. We go straight to extra large. That was an excellent question, Hannah. This is Space Radio. Don't forget to call 888-581-0708 to join the conversation, or catch the live streams on YouTube and Facebook, or Twitch. If you don't know what Twitch is, ask your kids. Hannah, are you on Twitch?
Nope.
Okay, so maybe don't ask your kids if your kid is Hannah. If you have somebody else's kid, or if you're somebody else with a kid, you should ask that kid about Twitch. We've got a little bit more time for just one more question. Give me something fast, Hannah.
Why do stars twinkle?
Why do stars twinkle? Excellent question. So a star is so far away, even though a star is like the size of our sun or even bigger. It's super far away, so it looks like a single point of light, just one point of light. And as that little beam of light enters our atmosphere is constantly shifting with cold flows and hot flows, and it's constantly mixing with winds and storms and everything that an atmosphere can do. And as that little beam of light hits a cold patch, it will bend one way. As it hits a hot patch, it will bend another way. Left and right, up and down, wiggle, zigzag back and forth. And so it's because we're looking through our atmosphere at that little point of light, we're looking at that little path of light constantly wiggling back and forth. So if you go up into space above the atmosphere, no more twinkle. Does that satisfy your curiosity? Thank you so much, Hannah. It was such a great time having you in the studio. I'm sure you have like a million more questions, but that is the beginnings of a scientist, is to start with a million questions. Maybe you get to answer 1 or 2 in your life. That is the career of a scientist. Once again, we're about to take a quick break, folks. Don't forget to call 888-581-0708 to join the conversation. You can also catch the live streams on YouTube, Facebook, and Twitch, and visit spaceradioshow.com for all the links. I'm Paul Sutter, and this is Space Radio. Is brought to you by you. Visit patreon.com/pmsutter to learn how you can support this show. Also, if you'd like to take a stargazing trip of a lifetime, go to astrotours.co. That's astrotours.co to learn how you can go on a trip with me. It would be so exciting. See you after the break. All right, so the YouTubers are complaining that your microphone was not working. I think I wasn't hearing Hannah in my headset, so I think it just wasn't piped out to me. It is not a dead mic. You have a recording. Greg has a recording. So you were good. We caught you. It just didn't get piped back to me and back to the live stream. Sorry about that, folks. Greg knows what he did wrong. Guys, if you want Greg to be a better producer, you need to go to patreon.com/pmsutter to support the show so that I can replace Greg with someone who's costlier but more competent. That's the deal. Thank you so much, Hannah.
Thank you.
You can go back and keep watching the show. And you just leave the mic like this, Greg? Live streamers are saying great questions, by the way.
Her teacher was tweeting.
And her teacher was tweeting.
Or twitching or whatever.
All right, we have a caller lined up. Okay, so I'll take the caller, and then I'll do that NASA directive news. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got another listener question ready to go, but to remember, you can join the conversation by calling 888-581-0708 or by joining the live streams on Facebook, YouTube, and Twitch. Visit spaceradioshow.com for all the links. We've got Jonathan on the line. Thank you for calling, Jonathan. Where on earth are you?
I'm in New Albany, Ohio. I'm just northeast of you.
Very cool. New Albany, Ohio. Thank you for calling. What are you curious about today?
Well, I was wondering, regarding black holes, the nature of a black hole and its density, how particles are, where they are, how close are they, and if a black hole emits a radiation throughout space and it will diminish in size as it radiates, then what happens to its substance as that happens?
That is a great question, Jonathan. The question is about black holes. It's about the evaporation of black holes. I mentioned this when it comes to microscopic black holes when I was talking to Hannah about how they can just disappear. Even bigger black holes can also disappear. We're pretty sure through a process called Hawking radiation, named after Stephen Hawking, who figured it out about 40 years ago. He figured it out. I'm saying we're not 100% sure about this because this is a question that lies at the intersection of gravity, which is how we understand black holes, and quantum mechanics, which is how we understand things happening right at the barrier of the black hole, right at that event horizon. And we don't fully understand how gravity connects to quantum mechanics. We don't have a quantum theory of gravity. We haven't figured it out yet. Maybe Hannah will figure it out. I don't know, but it will probably be a while because it's a tough problem. But if we're going to take Hawking's word for it, and he seems like a smart guy, he seems all right, that he knows what he's talking about, and he did the math, he checked it out. Black holes do evaporate through this interaction with what we call the quantum foam, this substructure to the universe that's constantly buzzing and vibrating with new particles constantly being created and destroyed. Sometimes these particles can be captured by a black hole and sometimes they can escape through very interesting quantum mechanical processes. And when that happens, the black hole releases energy, it glows a little bit, and the black hole evaporates. It shrinks, it loses mass, it loses energy. And if you just look at a typical black hole in our universe, one that's a few times more massive than our sun, a typical backyard stellar mass black hole that like everybody has, this black hole like this is emitting like 1 photon a year or something ridiculously slow like that. Black holes take an immense amount of time to evaporate, somewhere around 10 to 100 years. 10 to 100 years. Keep in mind the universe has been around for around 10 to the 10 years. So 10 to the 10 years is the current age of the universe. 10 to the 100 years is how long it takes for a black hole to fully evaporate. So it's not something we got to worry about for a while unless we're swamped in microscopic black holes. A tiny black hole can evaporate faster. And so it might go poof in a quick flash of light before it does anything else interesting. So black holes are evaporating. Black holes are glowing according to our current understanding of the intersection of quantum mechanics and gravity, which is something we don't fully understand, all right? But that picture might change, but in the current picture, that's what's happening with black holes. Thank you so much, Jonathan. That was a really, really wonderful question. Great follow-up to Hannah's question, by the way. I don't think we planned that. Jonathan was not a plant. We did not ask him to do this. It just happened. Before I go, I do want to get into NASA's new directive because the news just came out this week. NASA's new directive, signed by the Trump administration, is to stop caring about Mars. You know, all that Mars stuff we were talking about, how, hey, we got this great plan. We're going to go to an asteroid. We're going to lasso an asteroid into Earth orbit. We're going to study it. We're going to poke around with some pickaxes or something. I'm not exactly sure what we're going to do with that asteroid. And then that would give us the technologies we would need to head on out for a full-on mission to Mars, a multi-year mission where we're going to land people. They're going to go around, pick up the canisters left by the Mars 2020 rover. They're going to blast off, come back to Earth safely, and we throw a big ticker-tape parade. The Trump administration said, no, we're going to do something else, guys. How about instead of this whole asteroid Mars thing, how about we just go to the moon? I mean, we've been to the moon, right? So we can just dig up all the old plans. It's like right there. You can practically jump to it. And let's build a moon base or something awesome, right, guys? And it'll be huge, and it'll be fun, and it's a great idea. And I have to say, it's not a bad idea. And Gary Coleman on the YouTube live stream is saying he'll be happy with the moon base. Mars is maybe a little bit overrated. He'd be happy with a moon base. I'd be happy with the moon base too. I would also be happy with the Mars mission. I would be happy with anything. And there are honest to goodness trade-offs of going to Mars versus going to the moon, of which is better. Yes, the moon is way closer to Mars. So a mission to the moon can be a few weeks long, tops. And you can get some serious science done, and you can learn a lot. A mission to Mars is like a 2-year commitment minimum. 2 years. And that's a big challenge. That's a lot of risk. That's a lot of fuel. That's a lot of supplies. That's a lot of technologies that we'd have to develop. But on the other hand, Mars has water ice underneath its surface. It has carbon dioxide in the atmosphere, which means you can make water, you can make oxygen to breathe, and you can make methane fuel to get you back to Earth. You can mine Mars for resources to extend your mission life and to make it happen. The moon has got none of that. It's got none of that. So it's an honest trade-off. Moon is closer, but in some senses, a moon mission is harder, especially for long-term base colonization, et cetera, A moon mission is harder than a Mars mission in some respects. Here's my thing. I don't care what we do. Just do something. That's the challenge with NASA, is that every 4 years or every 8 years, sometimes even within a single administration, but definitely every time there's a new administration, there's a new direction. Say, okay, we're going to go to Mars now. We're going to work for 8 long years designing and prepping a mission to Mars. No, never mind. All that work, never mind. Instead, we're going to go to the moon, and we're going to spend 4 or 8 years working on a moon mission, figuring out all technology, doing lots of papers and presentations and lots of science and engineering, all that STEM goodness. And then, oh, no, never mind. Now we're going to go to a mission to Venus or Mercury, or heck, why don't we just skip the whole thing and go straight to Europa and check out those Europan space whales that we know are hanging around in the ocean of Europa. That is my challenge, where the mission, the directive of NASA constantly changes at least every 4 to 8 years, and even within the same administration. So I don't care what we do. I don't care what NASA does, as long as they do something and that they're given the lifetime to actually complete the goal. Thank you so much for Jonathan, the excellent question. Hannah for coming into the studio and asking her fun questions. All the live streamers, you guys are always a riot. You are very distracting, actually. You are incredibly distracting on the live stream, and I appreciate it. We're almost out of time today on Space Radio, but before we go, it's time for the Blue Shift. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift. And last week, this, by the way, is my opportunity to get a little bit closer to you. Last week, I wanted to go on a rant of the supermoon, but we had an extra caller, and I love answering questions, so I let the caller go through instead of the Blue Shift. Here's my rant on the supermoon, and it's a nice rant. It's a conflicted rant. I don't know what to think when it comes to supermoons. Supermoons get a lot of hype. They get a lot of advertising. They got a lot of media space. Your local weather person always goes nuts about the supermoon. And I love it when there are chances for people, excuses for people, reasons and reminders for people to go outside and enjoy the night sky. Because there's so much cool stuff happening in the night sky. But you think the name supermoon, that it's going to, I don't know, like it's going to be so bright, it's going to be brighter than the sun. You're going to need to wear sunglasses. Maybe it's the middle of winter and you'll be wearing shorts because it's so hot, the light from the moon. And then you go out and it's like slightly larger than average. Like 10% bigger, typically. That's cool, but maybe not quite deserving of the name supermoon. I mean, Superman isn't just slightly larger than average, man. He's Superman. He has soul. He can fly. He can shoot laser beams. He's Superman. Supermoon should be something cooler. The technical term for a supermoon is perigee-syzygy. Perigee means the moon is at its closest in its orbit around the Earth. Syzygy means it's lined up, which means it's a new moon. Perigee-syzygy, which I think is a way cooler term, but weather people don't usually listen to me when I say, let's just call it perigee-syzygy. It's better branding, I guess, to call it the supermoon. It's better copy for running advertisements and for getting people excited. So I love it when people get excited and interested about the night sky. I worry that the term supermoon is setting people up for a letdown. That is setting people up for disappointment. Like they're going to go and like, okay, what was that? And then the next time something really awesome happens, like, hey, everyone, there's been a supernova visible during the day. People are going to like, no. You got me with that supermoon. And it was kind of a letdown. I'm not listening in. I'm not going to pay attention. I'm not going to go and listen to space radio. I'm not going to go to patreon.com/pmsutter to help support any of that spacey stuff because you guys keep living it down or letting us down. That's my confliction. That is my honest goodness confliction, whether to keep calling it the supermoon, whether to keep hyping it. In January, Astro B is pointing out on the YouTube chat that there will be a blue supermoon in January, will be the second new moon in the calendar month, second full moon in the calendar month, and it will be a supermoon. So it's like super duper double blue moon. If that's even cooler, we'll see. We'll see. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is also brought to you by you. Visit patreon.com/pmsutter to learn how you can contribute. Thanks to Greg Moebius for producing, Dan Michalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. Call 888-581-0708 to join me on the air. You can also catch Facebook, YouTube, and Twitch live streams. Also follow me directly on Facebook, Twitter, and Instagram. That's at Paul Matt Sutter. Go to spaceradioshow.com for all the juicy details. And of course, thanks again, Earthlings, for listening. And remember, science is for sharing. End of transmission. Thank you so much, Hannah.